Hello everyone, welcome to today's session. Today we are dealing with tricky and lengthy questions asked in JEE Main, and some of the questions are already being asked. Some of the questions we are anticipating that can be asked. Okay, these questions are not a simple one, but not so in advanced level also. They are in the JEE Main levels. Okay, let's see you can solve it or not. The first question says match it. The question maybe seems to be simple when we are seeing the question, but while seeing the option, they are not asking only one property, they are asking more than one, right? So we should have a knowledge of periodic trends. In simple, I would like to tell you, we already posted a complete chart of the periodic trends, but here I'm telling you, as we are moving down the group, the size increases, right? And left to right, the size decreases. Okay. Then they are asking about electronegativity. This electronegativity, ionization enthalpy, electron affinity, all comes in the same category. You can take non-metallic character also. These all four increases when we are moving left to right in the period and decreases when we are moving top to bottom, top to down in the groups. Okay, so let's try to match it. The first thing is phosphorus with chlorine. Phosphorus, the atomic number is 15. Atomic number is 15 and the chlorine atomic number is 17. So which property matches to this one? Chlorine is having more size than phosphorus, electronegativity, ionization enthalpy, electron affinity. Which one? In case of size, phosphorus is more than chlorine, isn't it? So let's say the phosphorus comes here and the chlorine goes here. So phosphorus has having more size than the chlorine. And in case of electron affinity, it increases when we are moving left to right. So chlorine will have more electron affinity and ionization enthalpy will also remain the same. Electron affinity will also remain the same and non-metallic character will also remain the same. So except the size, except P, Q, R, S, T matches for A. Let's check it out. So once you know, the rest of the things will also get matched. Let's compare it for beryllium and boron also. Beryllium and boron, beryllium will have more size than the boron. In case of ionization enthalpy, there is a exception case. Beryllium is having more ionization enthalpy than boron because of completely filled shell. And then talking about sulfur and oxygen. Sulfur is having bigger size than the oxygen. And other properties, sulfur is more electron affinity than oxygen. But in case of non-metallic character, oxygen is more non-metallic than sulfur. Electron affinity also, oxygen is more electron affinity. Having more electron affinity than electronegativity than oxygen. So cool. So answer to this question becomes option A. Moving on to the next question. According to MOT, bond order of Li2, lithium 2 plus and lithium 2 minus. We have to take it as X and Y respectively, and they are asking for the whole number when we are adding X and Y. Okay. So lithium 2 which means total 6 electrons plus 1, so which it gives 5 electrons. And lithium minus 6 plus 1, 7 electrons. So for finding bond order, bonding electrons and then anti-bonding electrons divided by 2. So you will get lithium as 1s2, 1 star, 1s2 and sigma star 2s1. And for lithium minus ion, then 2 electrons extra excess than that, sigma 2s2, sigma star 2s1, right? So overall the bond order of this is 1 by 2, because 3 minus 2, 1 into divided by 2 becomes 1 by 2. Once again here also that becomes 1 by 2. So 1 by 2 plus 1 by 2, the answer becomes 1. Then the next question, how many pi bonds are present in this reactant? This kind of a challenging question, right? So who are all want to make some difficult questions, you can go about it. I'm giving you the 10 seconds. Please answer to these questions in the comments. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so let's solve it. They are asking for how many pi bonds are present in the reactant. Okay, the reaction goes like this: oxidative ozonolysis. So usually what I will say, if there is a double bond, just break the double bond, put double bond over there on both the sides, right? So the twist over here is that there are 2 moles of the product formed each, and one more twist is COOH group is here in the product, but there is no oxygen in the reactant. Either of the way you can solve this problem. One is finding the degree of unsaturation, and another one is try to find out the isomers of C12H16, or you can do the retrosynthesis also. I would like to go with the degree of unsaturation first. So what is the formula? I'm just taking for carbon and hydrogen. Hope you know the formula. So for carbon and hydrogen, 2C plus 2 minus hydrogen divided by 2. Along with that, sulfur, nitrogen, halogens is also there. So just 2C is 12 into 2, 24 plus 2, 26 minus 16, 26 minus 16 divided by 2, 10 divided by 2, 5. So total of either 5 pi bonds or a ring can also be included. Okay, so coming back to the question. So here I am having C double bond O, C double bond O. Okay, that can be of 1 double bond. And for COOH also, I should have a double bond. So let me guess the structure. The structure would be maybe something like this, where it can break and put double bond O, and further oxidation, this becomes the carboxylic acid. So 2 moles of acetone carboxylic acid is sorted. So remaining, for that part, you can take like this. Check with the carbon and hydrogen count. Okay. So here also you can break it. Put double bond O, double bond O, double bond O, double bond O. Okay. So this part will becomes one molecule and this part will become another molecule. So total 4 molecules. So how many double bonds are here? 4 double bonds and 1 ring. So total 5 as the degree of unsaturation. Okay. Hope you find this question challenging. Let's move on to the next question. The solution of phenol in chloroform is treated with aqueous solution. Aqueous solution of NaOH gives the compound P as a major product. Calculate the mass percentage of carbon. So this is a combination of organic with mole concept. So let's sort it out. Phenol with chloroform. What is the product? Here the student can slip to write what is the reaction this is. What is the name of the reaction? This is Riemann reaction. Correct. So what is the major product? That is what the important part over here. Usually we tend to write the major product as para position. But here it is a ortho position is a major product because of hydrogen bonding. Isn't it? So what is the formula then? The formula becomes C7H6O2. So the percentage of carbon, percentage mass of carbon becomes 12 carbon, 7 carbons are there. 12 is the mass of 1 carbon divided by total mass is 122 into 100 to calculate the percentage. So it becomes 68.55, approximately 69%. Okay. Then we are moving on to the next question. Liquid A and B form an ideal solution over the entire range of composition. At temperature T, equimolar binary solution of liquids A and B has a vapor pressure of 45 torr. At the same temperature, new solution, we don't know the mole percentage of that. A and B having a mole fractions chi A and chi B respectively, has a vapor pressure of 22.5 torr. The value of chi A divided by chi B is. So that is the question. So here we have two parts. The one is where we know the total pressure. So just I want to bring in a simple formula. Pure A into chi A plus pure vapor pressure of pure B into chi B. So total pressure they have given, that is 45. And what about the pure A pressure, that is 20 torr. They have given that is a binary solution. So binary means 0.5 as a mole fraction plus the pure pressure of B we don't know, and for mole fraction of B, that is I'm taking 0.5. So upon solving this, you will be ended up with pressure which is 70 torr for solution B. Okay. So what is the second part? That is a new solution A and B having a mole fractions chi A and chi B. So here we are taking the same formula. So I'm not going to repeat the formula. I'm just substituting the values. 22.5 torr, which is equal to, here I know the values of pure solvent 20 and mole fraction I don't know. So I'm going to take that as chi A plus 72R is the pure B into 1 minus chi A. That would be our chi B, right? So upon solving this, I'll be getting chi A as 0.95. So chi B, which is 1 minus 0.95, it is nothing but 0.05. Question not stopped here. So we have to calculate chi A by chi B, which is 0.95 divided by 0.05, which is equal to 19. Okay, 19 is the answer to this question. Moving on to the next question. This is a memory based, but once you know this, you won't do the mistake. So here they are asking oxidation state of sulfur in Caro's acid and Marshall's acid. So what is Caro's and Marshall's acid first of all? So I'm giving you the structure. Yes, double bond O, OH, O, OH. So yes, with 1, 2, 3, 4, 5 oxygens and 2 hydrogens. Similarly, what about Marshall's acid, which is having a peculiar peroxo bond. So in between I'm having peroxo bond. Sometimes they would ask what is the oxidation state of oxygen here as well. So be careful with these type of questions. Okay, so which is again having a formula of H2, 1, 2, 3, 4, 5, 6, 7, 8. 8 oxygens. So what is the oxidation state of sulfur? That is so simple. Once you know, then oxygen here, that is -1, so which here becomes +1, and here also it becomes +1. So total it is +6, and here again this sulfur also, that is +6. In case of Caro's acid, +1, +2, +1, +2. So overall that is also +6. So +6 is the answer to this question. Then the next question, in alene. What is alene? It is a exceptional, or you can take it as important compound when we are talking about the isomerism. Alene exhibits isomerism because of its perpendicular structure. Okay, so question is that C3H4 alene, the hybridization of carbon is. So alene which is having a adjacent double bond. Okay, so what is the hybridization of carbon over here? There are two types of carbon. One is a center carbon, another one is a terminal one, right? So the terminal one, as you can see, 2 hydrogens with a double bond, right? 1, 2 hydrogens, and then a double bond is there. So hybridization becomes sp2, and the center carbon is having 2 double bonds only. So sp and sp2. That is the answer to this question. Then find the stability order of these ions. So carbon. So first of all, stability order, which is related to the bond order. So if bond order is more, stability is also more. That is the relation. So what is the bond order of C2 2-? As you can see, 12 electrons for carbon and plus 2 for 2 minus. So total 14 electrons. Here for oxygen 8 plus 8 16 plus 2 18 electrons, and nitrogen becomes 7 plus 7 14 plus 2 electrons, that is 16 electrons. So just find out the bond order of this, or else you can, by the practice, by the time you must know about this, but I'm giving you the values as well. For the 14 electron system, that becomes 3 as a bond order, 15 it is 2.5. We saw, we are going to see one question as well, and 16 that is 2, 17 that is 1.5, 18 1. Usually the questions will be asked like this, out of these category. So as you can see, 14 that is 3, 18 1, 16 2. So what is the order? 3 and then comes N2 2 minus and then O2 2 minus. That is the stability order. Then this question. This question seems to be a bit confusing, but trust me, this is easy, because they are asking how to achieve this product. What are the reagents we have to use? As you can see, what is the change over here is that CH2 became CHO, right? So what had happened? CHO means must have oxidation taken place, correct? So what the reagent we must have used? Let's take the first one, option A, that is hydroboration followed by oxidation, right? Oxidation with PCC. And second one H2O2, then PCC. Third one PCC only. Then we are doing the adenation. So more similar to the first one. Let me show you how. The first one, I'm having CH2. First, what will happen? Hydroboration means it will give antimargonic of, correct? Antimargonic of syn addition. So OH will goes as a CH2OH and hydrogen will get attached over here. Then as a next step, PCC. PCC is a mild oxidizing agent, so we can get easily primary alcohol to aldehyde. So answer to this question is option A. So first order reaction has a rate constant of 33.58 into 10 to the power minus 3 seconds. How long will it take for 5 grams of the reactant to reduce 3 grams? So this is the first order reaction. So you can go about with the formula. We know K is equal to 2.303 T half, or T, not G half, just a T, log A naught concentration A. So just substitute the values over here. So time we have to find 2.303, K they have just given 33.58 into 10 to the power minus 3 log of 5 by 3. So upon solving, you must be ended up with 178. So AX is a covalent diatomic molecule where A and X are second row elements of the periodic table. Based on the molecular orbital theory, the bond order of AX is, okay, so you can see second row they have given. So boron, carbon, then nitrogen, oxygen, fluorine. That is the elements in the second row which can form a atomic molecule. So out of this, it is forming AX. Both the atoms are different, and they are having a bond order that is 2.5. So among these, only NO atom, comparing the valencies, NO can only give this type of covalent diatomic molecule. And if you are finding out the number of electrons from here, that becomes nitrogen 7, oxygen 8, so total 15 electrons. We already saw 15 electrons will give to 2.5 bond angle. Sorry, bond order. So answer to this question becomes 15 electrons. Then N2O, which is N2O4. N2O4 dissociates to NO2 according to the following reaction. It is an equilibrium reaction, and delta G of the reaction at 298 Kelvin, 1 atm pressure. When 50% of N2O4 is dissociates in its equilibrium. Okay. How many of you can solve this question in a minute? I know this involves the calculation, so take 2 minutes. So try to solve this question. Pause the video, try to solve it. So N2O4 is giving 2NO, right? So initially it was 1 mole, 0, and then it becomes, the product becomes 2 alpha. So here it becomes 1 minus alpha. Okay. So for delta Ng, what is the formula? Minus RT ln minus 2.303 RT ln Kp. Correct. So for that we have to find Kp. So Kp, we know that is, for that we need to know the total moles, total mole fraction. For that, I'm going to divide it, the whole thing, by 1 plus alpha. So which gives us the total amount, total moles of the reactant and the product. So now find out the Kp. So just substitute N2O4, pressure of NO2, pressure of NO2 and N2O4. So substitute the values. You will be ended up with 4 alpha square. You will be ended up with 4 alpha square 1 minus alpha. So here you can take the values given in the question, that is alpha, that is 50%. So it become 0.5, isn't it? So I'm going to substitute the values. So 4.5 square by 1 minus 0.5 square, which will give you, so calculated at 0.75, 1 by 0.75, which is Kp 4 by 3. But they are asking for delta G. So minus 2.303 into 8.314 into the temperature given is 298 into log of, either you can take, okay, just put ln over here. If you are taking it in log, put 2.303. Here I'm using log. I'm taking 4 by 3. So upon solving, you must end up with minus 684.7. You can do the round off because there are only two values given and the answer will be of the negative and they are in the more distance, right? 300 and 600. So you can easily do the round off thing. Then 1.2 ml of acetic acid with the density 1.02 grams of gram per ml when dissolved in 2 liters of water. Depression and freezing point observed this much, and then find the dissociation of acetic acid in the solution. Given that water values are given, consider the molality as equal. Okay, so how to solve this type of questions? This is also involving the calculation part, isn't it? So you can go about it from finding the mass of acetic acid, that is they have given the density, volume 1.2 ml, both are in the ml units, so please be careful with the ml units, the units. So overall this becomes 1.224 grams. Then calculating the molality, so 1.224 divided by 60 as a molecular mass and the volume in liters. Okay, here we are taking as such because it is in liters. Okay, so they are talking about the freezing point, depression. So the connection between the freezing point and the boiling point is that delta TB equal to Van der factor Kf. Yeah, this delta TF Van der factor into Kf m, right? So Van der factor I into Kf, that is given as for 1.85 and m value 1.224, 16 to 2, 120 also you can take. And what about I value? So I value becomes 8. So upon solving this, you will be ended up with 1.0493. Okay, so that is I value. They are asking for the percentage dissociation. So for finding out the I, we know the formula which involves the dissociation constant, also dissociation value, that is alpha, 1 minus n minus 1 alpha. So we know the I value, that is 1.049, 1 plus 2 minus 1 alpha. So alpha becomes 0.0493. So to make it as a percentage, it becomes 5. Okay, so answer to this question becomes 5. Then the next question, they are having 6 reactions to be reacted. Upon seeing this, don't panic, just do it. Okay, it will take only 1 minute. Let's take. So first I am having benzene with nitration. It will give you NO2 with that is nitrobenzene. The second reagent, that is reduction. So I'll be getting aniline, correct? So then the third reagent, that is diazotation. So I'll be ended up with C6H5, N2Cl. Then the fourth reagent, that is CuCN. So diazonium salt with CuCN, it will give you C6H5Cn. Along with that, I'm having the fifth reagent as magnesium, methyl magnesium bromide. So what that will do, C6H5, Mg will, methyl group will get attached over here, and then I'm having nitrogen that is having MgBr. So as a sixth part, I'm having acid workup. So I must be ended up with C6H5 with methyl group and then double bond O. Along with that, NH2, NH, MgBr will be formed. Okay, so answer to this question is C6H5 COMe. Then this one, PT En twice Cl2. Which of the following is not true? They are asking. So just find out what type of ligand is there. That is AA2 B2. Correct. So AA2 B2 type means what is the isomers it can form? It can form cis and trans. Correct. This is a trans position, and cis one will look like this. So tell me, cis can exhibit geometrical isomerism or not? Optical isomerism or not? Yes, it can. So cis can give optical activity. What about trans? It does not show optical activity. So what are these options says? Two geometrical isomers, cis and trans, that is true. And both cis and trans can show optical activity? No. This is an incorrect statement. Only cis can show optical activity. Only cis has non-superimposable mirror images. So all these are right except B. Then this question, they are asking for the product. Okay. So upon seeing this Br2 is the dibromination. So whenever this kind of question comes, it will form a brominium ion as an intermediate. Okay, this type of question can also be asked. But here the question is that product formation. So what happens over here? Let's see. OH is there, double bond. So upon Br2 is attacking, it's taking up the one of those Br. So what will happen? It will form the brominium ion intermediate formation. It is not stable, of course. So it will break up and form a carbocation over here. Which will lead to this cycle formation, ring formation. How? This OH, this oxygen will come and attack to form a ring. So whenever you are playing with the ring, just remember to number it. So from oxygen 1, 2, 3, 4, 5, 6, 7. Okay, here only the ring stops, so we need not to take the 7th one. So 6-membered ring I have to draw, which will have oxygen in its ring. So it is forming a from oxygen, let's say 2, 3, 4, 5, 6th position. I'm having CH2Br, right? 6th position I'm having CH2Br, and in the 6th position I'm having another methyl also. Okay, so answer to this question becomes this kind of product. So hope this questions helps you. If you need more difficult questions, please let us know. I'll do the video on it. But it's up to you. Practice more and more questions. Know your pain points and do the practice accordingly. Okay? Only 1 week to go. Practice more questions. That's all I can say. Thank you. Bye-bye.